Can you hear me now?
Yes, sir.
Can everybody hear me now, or still there is a problem?
Yes, sir. Was
Okay, then let's start from the functional group portion of our course. This was just introductory lecture, so we will just learn about the basics or definitions of functional groups.
sir. हो रहा है आपकी तरफ से.
Okay, just a minute. जी, अब तो नॉइज नहीं आ रहा, अब कुछ बेटर है.
Yes, sir.
स्क्रीन शेयर हो रही सबके पास?
जी.
Okay, so as I told you, we will start from the functional groups. So what are the functional groups? Before that, maybe you already have all of you have heard about or maybe read about in your previous courses about hydrocarbons and different common functional groups like alcohols, carboxylic acids, ethers, etc. Have you heard about that, or do you know about any of these functional groups already?
Yes, sir.
Okay. What is the basic definition, or how can we classify, or how can we say that it is a functional group? So if we go at the definition, we can see that functional groups are specific group of atoms or group of atoms, or sometimes bonds within a molecule that are responsible for their characteristic chemical reactions. What does it mean? It means that there may be some specific bonds like double bonds or triple bonds in alkenes and alkynes, or some group of atom like OH group and alcohols, or COH group and carboxylic acids, or in halides we have halogens like fluorine, chlorine, or bromine. These are the atoms or group of atoms or bonds which are responsible for some specific reactions of that class of compound. If we have the same like double bond or same OH group or same halogen in different molecules, then their reactions or their reactivity would be similar to each other, because the chemical reaction or the properties that will be defined by that bond or that group of atoms, and that's why we call them functional groups, because their functionality is derived from that specific bonds or groups. And therefore we can say that these same functional groups, they will go under same or similar reactions regardless of the size of the molecule it is a part of. Means, for example, we have ethene. Most of you know that in ethene we have 2 carbon atoms, and they have a double bond between them. But if we increase the 1 carbon atom, and it will become propene, and then butene, and so on. So the size of the molecule is changing, but if we look at their general or characteristic chemical reactions, they will stay same. Can anybody tell me a specific reaction of alkene? Any specific reaction you have already read about in any course? Any one reaction of alkene?
Sir, addition reaction,
Additional reaction. Exactly.
hydrogenation,
Halogenation.
Yes. Yes.
hydrogenation.
Mhm. So these are all types of reactions that alkene can undergo. So even if now if we relate this one to the point that when we are comparing the size and the chemical reactions, then even we have a butene or propene or pentene in every of one of these molecules. If we add let's say HCl molecule or HBr, we react with them. So what will happen? These one of the hydrogens and one bromine, they will add to carbon atoms or that are making double bonds with each other. So that we call it additional reaction, because additional reaction is a characteristic reaction of alkenes and alkynes. uh, and every molecule, even if the size is small or large size, they will undergo the same type of reaction. The product may be different, but the reaction and the mechanism would stay same, right? Have you got my point about that?
Yes, sir.
Yes, sir.
Yes, sir.
And then there is another, if we go into more details, then maybe it's not necessary that every molecule have only one functional group present in that. There may be more than one different functional groups present in the same molecule. So if there are more than one functional groups present at the same time in the same molecule, then their reactivities can be modified, or their reactivities can be different than the molecules where there is only one functional group present in that. So these are some types you most of them maybe you are familiar with, of functional groups. Like first of simplest is in hydrocarbons. Hydrocarbons, are only composed of carbon and hydrogen. So the only possible configuration, except alkanes, they can have double or triple bonds. So in hydrocarbons we can have alkenes and alkynes, where they can have their specific reactions or their chemical properties due to that double or triple bond, or due to unsaturation. Then moving on, we can also have some groups where we have some halogen compounds, like from fluorine to iodine. Any element can be present, and that is making a single bond with carbon atom. So these types of groups, they containing halogens, we usually call them alkyl halides. The next is some groups or functional groups which contains oxygen. Do anyone know about any functional group that contains oxygen?
Carboxylic group.
Sir, ether,
Carboxylic
Yes.
group.
Yes. Ether, carboxylic group,
carbonyl, carbonyl,
car- carbonyl, and alcohols,
ester,
ester. They all have uh,
nitrobus,
what? Which one? Nitro? Yes, nitro
nitro.
also. Yes, oxygen. So these are all the different types of groups or functional groups which contains oxygen in addition to carbon and hydrogen. Because organic molecules, when we talk about organic molecules, they are mostly composed of hydrocarbons, or mostly composed of carbon and hydrogen. And then there are different other elements present in different type of molecules. So if we are classifying on the basis of that. So first we have seen that they can be also halogens, and if there are halogens and they are making a single bond with carbon atom, then we call them alkyl halides. And then in oxygen we have a wide variety, like if we have OH bond, then we call it alcohols. Then most of you told about carbonyl group, C double bond O, and that also have two different subclassifications, like aldehydes and ketones. Then there is carboxylic group, COOH, carboxylic acid. Then we have esters and ethers. So these are the subgroups in which we have oxygen in our organic molecule in addition to carbon and hydrogen. Then we have some groups where we have nitrogen present in them, like just someone mentioned about nitro group. Then we have amines, NH2 amides, they all contains nitrogen. The next, some of the molecules, they can also have sulfur in them, and some of the examples are SO2 groups or SO3 sulfonate groups, sulfonic acid
Thionyl.
functional, yes. SH group, this we can also call thiols. In comparison with alcohols, we call them thiols because alcohols are usually denoted by ols. Then phosphorus, P3O4, PO4, boron, some of them. So these are different types where we can see specific groups which are determining or which are defining the overall chemical properties or general chemical reactions of a molecule. Here is a list we already discussed with their general structures and some specific examples. For example, these one alkenes, alkynes, and then we have another similar analogous group is aromatic ring. That is aromatic. Do you know anything? What is the difference between alkene, alkyne, or aromatic group? Is there any difference? Aromatic group or cyclic alkenes?
सर उनमें रिंग शेप स्ट्रक्चर होता है और कभी कभी उनमें ऑर्डर ऑर्डर देते हैं वो
रेजोनेंस होती है.
Okay, is there any difference between cyclic alkenes and aromatic ring, or cyclic alkynes and aromatic ring? Because cyclic compounds, they have a closed structure. Even if you have a six-member ring like cyclohexene, so what would be the main difference between alkene or that aromatic ring? Let's say benzene.
अल्टरनेटिव डबल बॉन्ड्स नहीं होते.
So in aromatic rings we have alternate single and double bonds. But in if we talk about cyclic alkenes or alkynes or any other cyclic compound where they don't have alternate single and double bonds, that would not be an aromatic ring, because in that one we don't have that alternation. And what happens due to this alteration, this aromaticity or aromatic properties, these are derived from this alternating single and double bonds. And what does it results into? It results into delocalization of electrons. Have you read about the benzene structure and delocalization of electrons due to that specific structure?
Yes, sir.
So in that one we can also differentiate that aromaticity only that is derived from this specific arrangement of these bonds, and then as a result of that we can have specific properties of that aromatic ring and in terms of physical or chemical properties. Alkyl halides, as we discussed, they can have carbon and halogen bonds, and that is a single bond, and from fluorine, chlorine, bromine, or iodine, any one compound can be part of that molecule. In the last column you will see there are some they have written 1 degree, 2 degree, or 3rd degree, or we can say primary, secondary, and tertiary halides. Do you have any idea about that, why we call them primary, secondary, or tertiary halides? Because the general class is alkyl halides, but then we can further classify them into primary, secondary, or tertiary halides. Just like alcohols in the next class, they are also classified as primary, secondary, or tertiary.
Yes, sir.
So can anyone tell me why they are different? We differentiate between these classes. Can you please?
If alide ion is attached to a primary carbon, then it is primary halide, and if it is attached to a secondary carbon, then it is secondary halide, and same as tertiary.
So what is a primary, secondary, or tertiary carbon? The basic question is that
सर जो
why we
further
call.
एक
Mhm. Okay, go ahead, please.
प्राइमरी कार्बन बेसिकली वो कार्बन होता है जो कि वन अदर कार्बन एटम से अटैच होता है
Right.
और सेकेंडरी में टू कार्बन एटम से अटैच होगा और टर्शियरी में थ्री कार्बन एटम से.
Exactly. So it depends on the carbon atom that is bonded to halogen, and then we will see that carbon atom is further attached to how many carbon atoms directly attached or directly bonded. For example, in primary halides, if we see that this X or halogen is attached to this carbon atom, if this carbon atom is only attached to one other carbon atom, then it is a primary halide. If that carbon atom is also bonded to two other carbon atoms and also the halogen group, then it's a secondary halide. And if we have halide and that carbon atom that is bonding with halide or halogen group that is also attached to three other carbon atoms, then we can say it is a tertiary halide. And same is the case with alcohols, because it depends on the connectivity or bonding of that carbon atom which is bonded to the functional group. Then we have ether, R, O, R dash. I think most of you know why we write R and what is the meaning of this R here in this table.
Right.
That is alkyl group. And how do we write an alkyl group? If we remove one hydrogen atom from alkane, then it becomes alkyl, and it has one bonding capacity that can be bonded to any other atom or any functional group. So here R means alkyl group in all the columns or entries. And in ether you can see they have mentioned two different types of R's, R and R dash, because in ether they can be same alkyl groups or different. It's not necessary that we should have the same number of carbon atoms on both sides of oxygen. They can be different, like ethyl, methyl, ether. So in left we have methyl group, and in the right we have ethyl group attached to the oxygen. I think you can go through all of these molecules or functional groups, and most important we will discuss later is some of carboxylic acids, alcohols, esters, and then carbonyl compound, carbonyl group. We were already discussing aldehydes and ketones are the subclassifications of these carbonyl groups. Can anybody tell me about the difference between aldehyde and ketones?
सर कीटोन्स और एल्डिहाइड में डिफरेंस ये है कि एल्डिहाइड में हाइड्रोजन एटम होता है और उसमें दोनों तरफ जो होते हैं ना ऑक्सीजन के साथ वो कार्बोनाइल ग्रुप लग जाता है.
Anybody else have any other point of view about that, or everyone is agreed with him? So we can say that if these both classes, aldehydes and ketones, they have carbonyl group C double bond O present in them. But the difference is that in aldehydes, one of the and one end of carbonyl carbon is attached to hydrogen, and the other end is attached to alkyl group. But in ketones, these both ends of carbon atom, this carbonyl carbon atom, that is attached to alkyl groups. And in carboxylic acid we have COOH group, and then esters, anhydrides, amides. You can go through all of these to have a look at, and most of the molecules or functional groups you are already familiar with. Now let's talk about just in the start when we mentioned that we have a functional group that would most probably have the same chemical or reactions or chemical properties in all molecules of its classes. So we will further elaborate on that a little in this slide. For example, we have here alkenes and alkynes. You already know that their general formula is same. If you have a general formula of alkenes or alkynes, you can write different molecules in that class very easily, just changing the number of carbon atoms. And then alkenes or alkynes, what do they have in common? What is their most featured reaction? That is addition reaction. Like if we add or we react with some molecule, what will happen? They will add to these two carbon atoms. Two different parts of that molecule would add to this doubly bonded carbon atoms, and this carbon double bond atom, carbon double bond linkage will be converted to carbon single bond, just like in alkanes. And then there are different configurations or different conformations possible in both these groups, alkenes and alkynes. They can be acyclic, just like straight chain or branch chain molecules, or they can be cyclic, and in case of alkenes they can also have aromatic structure. The next we can see if we compare with next functional groups, first we would like to establish some relationship about intermolecular forces. I think this one is spelled wrong, so I will correct it later. Intermolecular forces. What are intermolecular forces? The forces that are present between different molecules, and they forces of attraction which held them together. They can be simple London dispersion forces, or they can be dipole moment forces. They can be hydrogen bonding, depending upon the functionality or atoms or the charge on the atoms present in that molecule. So if we look at these alkenes or alkynes, can we see any partial positive charges, or can we write any partial positive charges or partial negative charges on them, or they are non-polar molecules? What do you think? Are they polar or non-polar?
Slightly polar.
Alkenes and alkynes, are they polar or non-polar?
Slightly polar.
Okay. So you mean carbon hydrogen bond is a polar bond, right?
No sir, only in double bond or triple bond case में effect ज़्यादा होता है.
But overall they would have only negligible polarity in them. So we can say only possible intermolecular forces of attraction, that is London dispersion forces. Do you know about them? What is London dispersion forces of attraction or London dispersion? These are present between non-polar molecules. So we assume that when one side of the molecule, because electrons are revolving around the nucleus, so if in one molecule there are electrons on the left side of the molecule, then it will induce a dipole on it, and it will repel the electrons of the second molecule that is lying adjacent to that. So that's why there electrons of the second molecule will shift to the left side of the molecule, and there will be very temporary dipoles created in them, and due to that dipoles there will be very temporary forces of attraction between them, and that are called London dispersion forces, and they are very momentary or temporary forces, because electrons are revolving, so they are changing their positions. So after a few seconds their position will be changed and the dipole location will be changed. So these are very weak forces, but they are only present in polar molecules. Weakest of the intermolecular forces of attraction, if we want to establish a relative scale, then these forces of attraction would be at the lowest level of attraction, because they are very temporary forces. So they are forces of attraction, but they are very weak. And this is a general geometry of these three classes: alkanes, alkenes, and alkynes. We have, because in you have maybe read about the Vesper model of methane. And what is the geometry, or what is the structure of methane according to Vesper model?
Tetrahedral.
Tetrahedral. And the bond angle would be 109.5, right? In tetrahedral geometry.
Yes, sir.
So all the molecules in alkanes, they will have tetrahedral geometry. If they are more than one carbon atoms, then one of these hydrogen atoms will be replaced by another carbon atom, but the geometry would stay same, almost same. And similarly in alkenes, because now we have a 3-atom structure. So in 3 atom center, according to Vesper model, you have trigonal planar structure or bond angle of 120 degree. So in these molecules, according to that, we have the bond angle of HCH bond angle is 120 degree in all of the alkenes. And in alkynes, that bond angle is changed to 180 degree. These are some characteristic reactions of alkenes. So why we call as characteristic reactions, or in the start we stated about functional groups that they have same or similar kind of chemical reactions. So in this one, this table, if you can see they don't write any names of the molecules. This is just showing that if we have a carbon double bond, and the length of molecule doesn't matter in it. If you have 2 carbon atoms or more than 2 carbon atoms, 3, 4, 5, 10, or even more than that, they will undergo the same type of chemical reaction. What if we add HCl, HBr, or HI, they will add up to these 2 carbon atoms that are joined by double bonds, and the product would be alkyl halide, right? That is another functional group, because carbon is bonded to a halogen group, so we call them alkyl halides. And then there is another property of alkenes, that if we add water into them, they will undergo hydration. And if we react them with this chloro, bromo, or chlorine or bromine gas, their bromination or chlorination will take place. And the similarly last 2 reactions. So these are the characteristic reactions. You can write any molecule of that family here, and the product would be similar. Just the reaction length of the chain can change, but the product would look similar. The class to the product would be same. Any question about this section about alkanes or alkenes? Or anyone want to add something?
No, sir.
Excuse me, sir.
जी.
सर लंदन डिस्पर्जन फोर्सेस में तो इलेक्ट्रॉन इक्वली डिस्ट्रीब्यूट होते हैं, तो आप कह रहे हैं कि डाइपोल्स क्रिएट होंगे.
डाइपोल्स वो क्रिएट होंगे जब हम उसको एज्यूम करेंगे कि दे आर रिवॉल्विंग. क्योंकि इलेक्ट्रॉन स्टेशनरी तो नहीं ना होते, आर दे स्टेशनरी और मोबाइल और इन मोशन इलेक्ट्रॉन्स मॉलिक्यूल में?
सर इलेक्ट्रॉन्स मूव करते हैं, लेकिन वो अल्काइन तो नॉन पोलर है वो।
ठीक है, अब देखें मैं आपको, क्योंकि वो हमारा वो टॉपिक मेन नहीं है लंदन डिस्पर्शन फोर्स, मे बी नेक्स्ट लेक्चर में आपको मैं वो उससे ग्राफिकली भी समझा दूं, लेकिन आप ये देखें समझें कि फॉर एग्जांपल एक मॉलिक्यूल है हमारे पास अल्केन का और दूसरा भी साथ, क्योंकि एक मॉलिक्यूल उसमें आप कह लें कि आइसोलेशन में तो नहीं ना होता, उसके साथ और भी मॉलिक्यूल्स हैं साथ सराउंडिंग में। अब एक मॉलिक्यूल में जो इलेक्ट्रॉन रिवॉल्व कर रहे हैं, लेट्स से वो एक पॉइंट पे हैं, कहीं भी किसी भी पॉइंट पे, ए पॉइंट पे, और उसके साथ जो दूसरा मॉलिक्यूल है उसके इलेक्ट्रॉन भी रिवॉल्व कर रहे होंगे या वो स्टेशनरी होंगे?
यस सर।
दोनों के कर रहे होंगे ना रिवॉल्व। तो अब
Yes.
एक जब वो इलेक्ट्रॉन्स रिवॉल्व कर रहे हैं, लेट्स से ए पॉइंट पे हैं, तो उसकी वजह से क्या होगा, वो जो नियर बाय आपका मॉलिक्यूल है उसके इलेक्ट्रॉन्स को रिपेल करेंगे या अट्रैक्ट करेंगे?
इलेक्ट्रॉन रिपेल करेंगे।
रिपेल करेंगे, ठीक है। और दूसरा ये होगा कि अगर इलेक्ट्रॉन्स ऑन वन साइड हैं, ये हम एज्यूम करें, मुख्तलिफ थ्योरीज हैं, अगर वो
Yes.
इलेक्ट्रॉन ऑन वन साइड हो गए उस मॉलिक्यूल की, आप कह लें कि अगर हम उसको हाफ करते हैं तो वो लेफ्ट हाफ पे ज़्यादा है और राइट पे कम है, तो क्या होगा, लेफ्ट हाफ पे बिल्कुल
Positive.
टेम्परेरी पार्शियल नेगेटिव चार्ज आएगा, ठीक है।
Yes.
और उसके जो सराउंडिंग वाला है, क्योंकि उसमें इलेक्ट्रॉन्स को वो रिपेल कर रहा है दूसरों को, तो वो उसकी दूसरी साइड पे चले जाएंगे, और वहाँ पे जो जहाँ पे पार्शियल नेगेटिव फर्स्ट मॉलिक्यूल का आ रहा है उसके बिल्कुल साथ वाले में क्या होगा, पार्शियल पॉजिटिव चार्ज।
Yes, sir, समझ गया।
ठीक है, इस वजह से इनके दरमियान, लेकिन ये दे आर वेरी टेम्पररी फोर्सेस। Why? Because electrons are not stationary, so they are changing their positions, and when they change their position, the location or position of dipole also changes. So these forces are not purely dipole forces. They are, we call them exactly dipole induced dipole forces.
एक्सक्यूज मी सर।
जी
सर पोलैरिटी ऑफ हाइड्रोकार्बन्स को एक बार फिर से एक्सप्लेन कर दें स्टूडेंट्स।
पोलैरिटी हम एक्सप्लेन नहीं कर रहे, हम कह रहे हैं कि इसमें क्योंकि ये नॉन पोलर हैं, तो इसमें आपके वो ना तो पोलर चार्ज कोई होगा, ना आपके डाइपोल्स क्रिएट होंगे, तो वो जो स्ट्रॉन्ग डाइपोल फोर्सेस होती हैं वो यहाँ पे प्रेजेंट नहीं है, ठीक है। यहाँ पे वेरी वीक फोर्सेस हैं जो क्यों हो रही है, वो वेरी शॉर्ट टाइम के लिए, जहाँ पे अगर कोई एक साइड पे इलेक्ट्रॉन डेंसिटी ज़्यादा है तो वहाँ पे इलेक्ट्रॉन के ऊपर पार्शियल नेगेटिव चार्ज आएगा, और उसकी वजह से फिर क्या होगा, इंड्यूस्ड डायपोल क्रिएट होगा दूसरे मॉलिक्यूल में जहाँ पे पार्शियल पॉजिटिव चार्ज आ जाएगा। अब ये जो अपोजिट चार्जेस हैं ये क्या करेंगे, एक दूसरे को आपको पता है अट्रैक्ट करते हैं, तो वो जो दो फोर्सेस हैं ये अट्रैक्शन की, इसकी वजह से ये मॉलिक्यूल्स एक दूसरे के करीब रहेंगे या इनके दरमियान अट्रैक्शन, फोर्स ऑफ अट्रैक्शन रहेगी। अब आपने शायद देखा होगा जितना मॉलिक्यूल बड़ा होता जाएगा तो क्या होगा, उसमें आपकी जो ये चार्ज डेंसिटी है इसकी डिस्ट्रीब्यूशन ज़्यादा वाइड होना शुरू हो जाएगा। अगर मॉलिक्यूल बड़ा होगा तो हो सकता है उसमें आपके ये जो डाइपोल्स बन रहे हैं टेम्परेरी, इनके चांसेस ज़्यादा हों, तो उसमें थोड़ा सा जो इसका चांस है लंदन डिस्पर्शन फोर्स का या इनकी जो मैग्नीट्यूड है वो स्मॉलर मॉलिक्यूल्स के मुकाबले में हो सकता है ज़्यादा हो। ठीक है, नेक्स्ट चलें।
Yes, sir.
Okay. Now we have grouped these three functional groups. Already we discussed that there are many functional groups. Not only these three functional groups that contains oxygen. But why we have selected these in a group? Because you can see they have in all of them. If we see, they have carbon oxygen bond in all of them. Then there is something else in carboxylic acids and alcohols. You can see there is oxygen hydrogen bond, right? And then when we compare this to these bonds, carbon-carbon single bonds and carbon-hydrogen bonds. These bonds were we were already discussing, they are non-polar. But what about these bonds, carbon-hydrogen and oxygen-hydrogen bonds? Are they polar or non-polar? Carbon-oxygen bonds and oxygen and hydrogen bonds. If we compare them with
Polar.
carbon-carbon,
Polar bonds.
सर पोलर है
polar है, ठीक है. Carbon oxygen is polar, oxygen hydrogen is also polar bond.
Polar bond.
So they have a strong polarity within these molecules, and due to these molecules we have dipoles in them. And if we have dipoles, then what force of attraction we can have, we can see in them dipole-dipole interaction. Is that stronger force than the London dispersion force, or similar
Yes,
magnitude?
sir.
That is
Stronger.
stronger than. So in all of these molecules, if we say due to carbon and oxygen bond, they have higher amount of dipole-dipole forces. Then we compare these on the forces of attraction with alkenes and alkynes. Then if we move on to next, oxygen hydrogen bond and alcohol, and then oxygen hydrogen bond in carboxylic. They are also polar, but they are highly polar. And for that one, maybe you have read about hydrogen bonding. So if you compare alcohols, carboxylic acid and esters, which of these functional groups can have hydrogen bonding present in them?
Sir, alcohols.
And alcohols, okay. Can esters have hydrogen bonding in the
No, sir.
can-
Carboxylic acid.
No, sir. No, sir.
and how about carboxylic acid?
Yes, sir.
They have.
They have hydrogen bonding. So in addition to that, London dispersion forces, or we can have dipole-dipole forces, and in the next, in carboxylic acid and alcohol's case, we can also have hydrogen bonding present in between them. So the forces of attraction between these molecules, that are called intermolecular forces of attraction, that would be stronger than alkenes and alkynes, and that would also affect their properties and general properties. And similarly, as we are discussing that OH group, if we have alcoholic group or OH group in any molecule, it would have a different set of chemical reactions that would stay similar in alcohol family. And in this ester group, if we have this linkage COO linkage, they will also have their own set of specific set of general chemical reactions and general chemical reactivity trends. So they will also follow similar pattern, just as we discussed earlier. And also in carboxylic acid, they will have same. And this is a depiction of their structures. Here oxygen is shown as red, and you can also see double bonds. So this is the structure of different these three classes of compounds. And here is an overview of alcohol's general reactions, what type of general reactions they can undergo. For example, the first is oxidation. So if an alcohol goes under oxidation, it can produce a carboxylic acid at the end product, or in the intermediate product we can have aldehydes. And then there is a difference that if we have primary alcohol or tertiary or secondary alcohol, then what would be the product? So if we have primary alcohol, we can have carboxylic acid at the end. But in secondary alcohols, they have ketones, and tertiary alcohols, they don't show any reaction with them. And if we talk about dehydration, then these are the products and different conditions the alcohols go. So if we have any alcohol here, irrespective of the chain length, they will undergo the same type of chemical reactions. So that's why we have grouped different these functional groups, and we call different compounds as classes of different compounds, because it's easier to study them, and it's easier to predict their general chemical reactivity. Just like in periodic table, we have arranged that elements into groups and periods. So if a group if element has the same group, two of the elements have the same group, can we relate them with each other according to their some properties or not? Elements of same group in a periodic table. Can we say they have similar types of reactivities, or it's wrong? Anybody tell me?
Yes, sir.
Why do we arrange different elements in groups and periods? Because it's easier
Convenience.
yeah, for convenience, and it's easier to study them because there are some general properties, they stay same in a group, and then in a period we can predict easily if they are in a period, and according to their location we can predict different properties according to their position in a periodic table. Similarly, in organic chemistry and different functional groups, we have classified them into different categories. So whenever we have alcohol and someone asks you that this molecule, they didn't tell you that this is an alcohol or this is a carboxylic acid or it's an another functional group, and they give you the reactants like butanol and potassium dichromate, K2Cr also, and they will ask you and to predict what type of products they can form. So if we didn't have any classifications, it would be very difficult to predict. But because we have different classifications of functional groups, so first you can see what type of functional group is present in that molecule. In butanol, let's say we have a OH group. So now you can limit your possibilities to the reactions that can take place in alcohol. And then you can see this general reaction with K2CrO7, that if alcohol is reacted with potassium dichromate, potassium chromate, then what are the possible products? And on the basis of that, you can easily predict that. And if you don't have any classification here, then it would be very difficult to predict or study that class or that compound independently, every molecule independently. These are the general reactions of carboxylic acids. For example, when they are treated with alcohols, they form esters, and when they are treated with any base, they change into an ion, carboxylate ion, which can further react to another species and form another product. And here is a general reaction of esters. You don't need to memorize all of these reactions. These are just for the giving you a general concept of the functional group, why we classify them into a functional group, and what is the reason or what is the benefit we get from that. This section is we already, I think, discussed a little that what type of intermolecular forces of attraction are present in between them. Please note they have mentioned about non-covalent interactions, because these are all mostly non-covalent interactions. In alkanes or hydrocarbons, alkanes, alkenes and alkynes all included, we only have induced dipole, London dispersion forces. While in just like we saw in esters, we can have dipole-dipole interactions, and in alcohols and carboxylic acids, we can also have hydrogen bonding just like this present in between them, because they involve oxygen hydrogen bond. And you know that for hydrogen bonding to occur, there should be a very large difference in electronegativity of the atoms. And can anybody tell me, if we one of the atom is hydrogen and we want to predict that is there any hydrogen bonding present in between the molecules, what other molecules, what other atoms can be attached to oxygen atom, oh sorry, hydrogen atom, that would result into hydrogen bonding? For example, here we have oxygen atom. They have a large electronegativity difference. That's why they result have a stronger dipole forces of attraction that we term as hydrogen bonding. Any other element which can have the same effect other than oxygen?
Fluorine.
Okay.
Nitrogen.
Okay. And
Sulfur.
Nitrogen.
see the difference, the definition or the basics of hydrogen bonding is that there is a very large difference of electronegativity between these elements, and we know that hydrogen has the lowest electronegativity. Am I right? Which of the elements has lowest electronegativity? Hydrogen, or is there any other element? Which of the atoms or elements have lowest electronegativity? Is it hydrogen or not? Hydrogen. Okay. And we want to see the largest difference in electronegativity so that we can predict hydrogen bonding, or we can say there could be hydrogen bonding present in the molecules. So naturally, when will be the difference, when we would have the highest difference? When the other element will have very high electronegativity. So you will look on the periodic table, where are the higher electronegativity atoms located. So in a periodic table, usually which position is more suitable, or which position is predictable to be having higher electronegative atoms? That is top of the group and right of the periodic table. Am I right? Because electronegativity, maybe you have studied already that electron, when we move from in a period from left to right, electronegativity increases or decreases?
Increases.
Increases. So it means that element at the right end of a period would have highest electronegativity in that period. And the second trend we studied in a group is that if we move from top to bottom, the electronegativity
Decreases.
decreases. So it means the atom at the top of the group would have the highest electronegativity in that group, right? So now we have two observations here, that if an atom is present at top of the group, it would have highest electronegativity in that group, and if it is located at the right end of the period, it would have higher or highest electronegativity. And if we combine these 2 points, then what would be the element that would be having the highest electronegativity? Top and right?
Sir, fluorine.
Yes. So top right is fluorine, or near these fluorine there can be 2 or 3 other elements which have higher electronegativities, which have
Nitrogen.
higher scales. So these elements, if they are bonded with hydrogen, then that molecules can have hydrogen bonding, because there is a large difference of electronegativity in between these elements. So most of you already answered correctly that it can be nitrogen, it can be oxygen, fluorine, or similar elements which have very high electronegativity. When they are bonded with hydrogens, then those molecules can have hydrogen bonding in them. Because of course there are dipoles, but if the dipoles are very strong and they involve in hydrogen, then we term it as a hydrogen bonding. So for today we will end our discussion here, and in next lecture we will study some other functional groups. There's some general properties or features, and we'll continue our lecture, I think, hopefully from Monday in physical lectures. Any question from students?
No, sir.
सर ये आप प्लीज स्लाइड शेयर कर दें.
ये मैं आपको कर आप इसमें जो है इसको मैं फाइल्स सेक्शन में रख दूंगा आपको, तो वहाँ से आप डाउनलोड कर सकते हैं. ठीक है, टीम्स के फाइल सेक्शन में अपलोड कर देता हूँ. अभी आप लोग लीव ना कीजिएगा, मैं अटेंडेंस ले लूँ, उसके बाद आप 1 आवर की है ना आपकी क्लास?
जी सर.
Please, sir, this is class start.
जस्ट अ मोमेंट, उसके बाद आप लीव कर सकते हैं, मैं अटेंडेंस ले लूँगा. ओके जी, थैंक यू. एंड